Hello guys, welcome back. Well, we're going to complete installing parts on this board for this Homebrew spectrum analyzer kit from March 90, or I should say February 1990, 73s. Anyway, the only reason I say March, it actually says M-A-R 73. See that? M-A-R. So maybe it was actually March. Perhaps the article came out in the Centuries magazines in February. But perhaps this board wasn't started to be manufactured until March in 1990. Who knows? Anywho. So, anyway. Right now we are going to install some diodes at the moment. We've got 3 diodes. We got one there, and one there. And according to, they're all 1N914 diodes. All 3 of them. So we just got to make sure we get the polarity right here now. So this diode there goes that direction. This one goes that direction. Yeah, no, I don't like the way this sits. I think it's spaghetti time. What do you think? Let me see if I get some spaghetti here. Here's a nice piece of spaghetti. Alright. Spaghetti on, let's see. Actually, I think I'll put it here. I like to get it so it kind of sits same as the body of the diode, something like that. Alright, so that one's got to go here. That one goes right there. I got that diode put in. Now we've got another one right here, which goes between these 2 points here. And she's banded that direction, same as the other one. So we get some more skitty. Spaghetti on that. That one goes here to there. Alright. Then we've got another one right here with the D3. Which connects between here and here. Now I'll get some more skitty. Alright. That one goes there to there. Alright. 3 diodes. Alright, let's get 3 of those colors soldered in now. Get these guys soldered in. Trim off the excess wire. Alright. So we got all the diodes in. There's 3 diodes. Still got a varactor, but we'll leave that one to last. Now we've got an inductor, which is L1, 150 to 300. And she sits right there. Maybe this inductor here. I'll put this one straight down. She might actually sit right on the board as it is. Let's see. And it does. Okay. So we'll solder him in there. Alright, what else do we got here? And we got C3 right there, which is a mica capacitor, which is this one here. So she would go right there. That's where that one goes. That one goes there. And let's see. And there's C2 up here at the top. And there's a little electrolytic. Calls for 0.33, 0.33. And the closest I got is 0.47. I don't know if there's enough messing up or not, but put it in there. There. That goes there. Yeah, another one. C1. Do we got another capacitor? C2, C3. I don't see a C1 on this diagram. So maybe you're supposed to go between here and here. Let's see. C1 goes between pin 2 and ground. Pin 2 and ground. Yeah. So between pin 2 and ground is this one. That one goes there. That one goes there. Yeah, what else we left with here? BC1. It's where we put in the varactor. Let's solder all these parts down. Alright. Check, make sure we got no short circuits. And as we sit right now, we do not. Alright. So far, we're doing good. Okay, so now we got to put in our varactor. According to is a 15 picofarad MV2105. MV2105. Now, that's the varactor diode right there. So I'm going to put him in the board. But before I do that, I'm going to verify the direction that that has to go in the board. So stand back. Okay. So it's a TO92 case, and according to the pinout, pin 1, pin 2. So the TO92 case, pin 1, pin 2. So there we go. We got our direction. Alright, let's put it in. So the varactor has to go this direction. Varactor diode. Alright. Solder him in. So, that is the finished board. So we got a few outputs here. Inputs, outputs. So, down here is 12 volts input, 12 volt DC. Tuning capacitor of the radio would go here. Ground would go here. And trigger for the scope connects over here. So we have all the parts. The board is fully populated. Just gotta plug in the 555 chip. But other than that, there should be. Let's plug in the 555. Okay. Get the 555 put in. So there is the populated board, folks. There it is. In all the glory. There you go. Alright. I think that's pretty cool, if I gotta say so myself. Question is, if I hook power up to this there now, will I see a signal on my scope? If I hook my scope up to this thing. Hey guys, I've got a little steel box here. Aluminum box. And it says in the article that it should be put into a shielded case. So I've got this one. Get two B and C, so one side can connect to the scope and the other side can connect to the receiver. It's got power input on this side, so that's pretty much all I need. But the problem that I have with this is that this board is a shade bit too big to fit. Just a shade. So I'm thinking, just thinking, that maybe I could shave down the board so much, because there's, there's a fair bit space on this side that can be cut clear, can be cut down, and as well as this side. And I'm thinking that if I cut the board down a little bit, that I can actually get this board to fit inside of this. At least that's what I'm thinking. I mean, the board will definitely fit there, there's no doubt. So, great little case for it. So I'm thinking that's what I'm going to do. Cut down this side, and then cut down this side a little bit. You don't, like I say, it doesn't need to be shaved off that much. Doesn't need to be shaved off a whole lot. But this case would definitely be perfect for this. So that's what I'm going to do. I'm going to shave the board down. If it don't fit, make it fit. Hopefully. Anyway, let's get it on. See what happens. Okay, so I got the board cut down a little bit smaller. And now the board will fit inside of this one without any hassle. When I put the board in, I'll put it from this side here. Then you're probably asking yourself, how is he going to secure the board? Well, a 3M two-sided tape is a wonderful thing. What I'll end up doing is two-way tape the board down to this one, right, down to this bottom cover, and then it'll slide up here, and Bob's your uncle. Then I can connect my connections, and then we're done. So let me get some two-sided tape, and I'll be right. Okay, two-sided tape is on there. Now, a lot of people wonder, what's the point of keeping old circuit boards around? Well, here's a prime example of why you should keep circuit boards around. Because they come with nice pieces of hardware, like Exhibit A, Exhibit B, Exhibit C, and Exhibit D, right there. These little tabs run an old circuit board that I scrapped. So now I can make my connections to those instead. So my power is on this side, and according to the diagram, so we orientate it this way, and that way power will be on this side of the board. So the board will sit there, sit like that, and go in like that, and then I can make my connections directly to those tabs, which I think is pretty awesome if you ask me. Anyway, that's my story and I'm going to stick with it.